Hello guys. So in this video we're going to be talking about basically interacting with external contracts. And in this case we're going to be looking at compound finance. So basically compound finance is a lending protocol. So what that means is that you actually can lend your tokens to them. In this case, Ether. You can actually lend any token that is they support a couple of tokens, USDC, DAI, and a host of other tokens really. So what do you mean by lending protocol is that you lend and then you earn interest on your lendings basically. And how these interests are actually accrued is that because they are a lending protocol and they have enough liquidity, people can also come and borrow funds from them. And these people that borrow funds, these people that borrow funds, they pay interest on their funds, and these interests are then distributed to the lenders. So from borrowers to lenders is how the profit is made basically. And compound is like well, one of the biggest, if not the biggest, lending protocol out there. So we're just going to be looking at how it is done, how to interact with their contract, how to like make use of these lending protocols, because this is what most DeFi companies use right now. So just gonna open up Remix. Basically what like we should just consider smart contracts like an API that you can actually call in this case. So unlike Web2, where most times or sometimes you'd need something like an API key to access API endpoints. In terms of smart contracts and Web3, this is absolutely not needed. Yeah, as long as the contract is deployed and you know the contract address, which is actually out there, then you can interact with that contract basically. So what you just need is the what we call interface, which is just like a framework of how the contract is written, like the functions you'd want to call that are in that contract. That's all you need. And that's like very easy to get basically. So you can get, like I said, easy to get, you can get this, it depends on the contract you're trying to interact with. Some of them have this in their docs, or you can actually go to their deployed contracts and just check through the API to see the functions basically. So yeah, so let's just dive into writing the code really and see how this works. So basically, like I said, what they do is you give them your funds, your say Ether. We're going to be dealing with Ethereum Ether in this case. So you give them your Ether, you deposit it, and each passing block, your Ether is going to be an interest. The interest is that's why it's actually a compound interest stuff. So your deposit earns interest every passing block, and we're going to be seeing how that is. So let's just call our contract let's call it investor. Yeah, I guess that's a nice name, I suppose. So yeah, so we're just going to call our contract that, and so first, so what are the things we're going to be needing basically? Well, supposing we want people to come, want to be getting funds from different users. This is not just for our use. So what you do is you want users to come deposit in your contracts, and then you take the funds that they deposit in your contracts and then deposit it on their behalf to compound, and compound gives you interest. And so at the end of the day, when they come to withdraw, you can choose to actually give them all their withdrawals with all the interest they've earned, or you want to make a little bit of profit for yourself, you can actually take some of those interests since you actually did some of the work for them really. So yeah, so that's basically the theoretical gist. So let's just get to working on it. So first we need like I said, we need this contract address of compound ether to interact with it. So I already have it somewhere. I'm just gonna copy it. But it's like it's not something that's really hard to get. Once you go to your site, their documentation, which is going to be really helpful if you want to work with it, and you click on the C tokens, you're going to see they actually have all their C token addresses somewhere around there. Yeah, so you just pick the chain. So maybe you have CF, which is like the Ether version. This is C BAT or DAI. So it depends on the token you want to borrow and lend. So in this case, we want to be dealing with Ether. So CF means compound ETH, basically. So you deposit some Ether, and then in return they give you a compound ETH, which actually represents your portion of the portion of your holding on compound finance. So basically, it's like if you have compound ETH, it's going to like it's going to represent your holding in compound. It's going to specify the I don't know specify that word, but it's going to just once you have compound ETH, it represents that you have ETH deposited in compound. That's just it, basically. So basically this is just the contract address that I was talking about, the CF. So copied it, and get it here, really. So I'm going to call it compound CF address. Yeah, so basically we have to make this into like a callable variable. We want to make it into a variable that we can actually call easily. So what we will do is wrap it in this interface. So we wrap this in this interface so that we'll be able to like call all the functions within. Now these functions are the major functions we are going to be dealing with. They are functions that belong to the compound contract, which is the mint. What this mint function does is just actually deposit. So what it means is that when you call the mint function, you pass in a message of value, which is the ether you want to deposit, and then it's going to like take your ether and then it's going to mint compound ETH to you. So that's just what the mint. So it's just like deposit function. So yeah, so we're just going to do a CF and call it set, and then we're going to have this one. I'm sorry. Yeah, so it's basically how it's going to work. We're going to be having a couple of other variables like to hold balances, like I said. So if you want users to come deposit in your contract, then you want to actually record how much the users deposited. And so we're going to be having a normal mapping to get balance. So we could do a mapping of an address to units. Yeah, and you can call that the set balances. So this will represent the set balance of the user. Since when you deposit to AAVE, when you deposit to compound, compound gives you set. So we want to keep the set that belongs to that user, basically. So yeah, what other variables would we need? Well, I guess we'll find out as we go on, but this one should got it for now. So let's get started then. So first function we want to have is a function that allows users to actually deposit to our contract. Yeah. So so they want to basically add balance to our contract. So it could be function add balance. Yeah. Takes nothing. Make it public so that we can call it. I also make it payable so that I can accept Ether deposits. Then yeah. So now in this function now, once we receive F from the user, what we want to do instantly is take that F and give it to compound. So inside this function, we're going to have another function call. So we're going to have an internal function that actually takes care of depositing to compound deposit. Yeah, and this is going to take the value. This is going to take the value. Value. Let's call it value. So and it's going to be internal because we do not want users to call this one directly. We want to call it from our contract. Yeah. So from the add balance function, we can then call this deposit and pass it how much the user is trying to deposit, which is value. That's it. Yeah. So this would deposit, and this will take care of the deposit. So have it now to compound. Now, how do we deposit to compound? Yeah, this is where it gets tricky. So what we do is called set.myth. Like I said, myth is what's responsible for depositing. So we do set, which is we already made it to call a callable variable here dot mint. So we're able to call the interface function mint. So we have to call it with the value. So we could do like this. So if you want to send value with your contract call, this is how you do it basically. Value. Well, let's just call this amount really, because it's not actually nice to name your variables as a like a non-variable sort of. So let's just call that one amount, and then we know that we're depositing that amount, and then we just call it. So we're calling set.myth. What it does is you're trying to deposit this value to compound really. So after we do that, we do set.mint, and then we then basically this once we do this, we've already deposited this amount to compound, and compound has minted CF to us. Now, because we are depositing on behalf of users, compound is actually minting the CF to our contracts. So now we have to allocate the users, we have to allocate it appropriately to the user who is actually depositing, since it's not a contract that's depositing, it's the user that's depositing. So what we could do is first get the balance of our contract before the user made this deposit. So what we should do is first get the balance, and we do that by calling the, as you can see, the interface already has a balance of. So we do that by calling the balance of basically. So we do something like self dot balance of. So balance of we want to get the balance of the user, which is balance of our address. Sorry, since the set is limited to our address. So we are doing the address into like this, and once we do that, we we have the contract balance before we actually, so we should actually do this before we mint and after, really. So what we want to do is get the amount of set that was minted for this particular transaction, really. So that's why we get it before and then after. So we basically just get this balance now. Let's just call it set balance before minting. And then we call the second one set contract set balance after minting, basically. So now the difference between these two is what is going to be used as the user's proportion, really. So remember, we have a balance. We have a variable that would set balances of addresses. So it will actually set balance of our user. So like I said, we are going to find the difference, which is going to be the user's deposit, the user's set equivalent, really. So we paste this, and so as you can see, we're getting set of user, which is the set of contacts after minting and then the one before. So the difference is what belongs to the user, and then we can then, you know, like register it in our variable by doing set balances of the message sender is equal to set of user. Yeah, so that's so this is basically so we're almost done with this deposit function. Now we've deposited to AAVE and we have recorded it appropriately to the user. And so I mean that's basically all that there is to be done. Now, so at this point we have deposited to AAVE and the user already has the balance recorded on their in their account, basically. So we are keeping track of users' balance now. So next thing that we want to do is you know, some function to withdraw, really. Now, once the user wants to withdraw, we obviously call the redeem function. Now, as you can see, there's a redeem and then there's a redeem on the line. So this actually does different things, really. If we go to the compounds documentation, we see that there's a redeem, and they say that the redeem function converts a specified quantity of C tokens into the underlying asset. So what this means is that you pass in the amount of C ethers that you want to withdraw, and then you get the ether. You get the ether equivalent. So if you pass in, say 1 Seth, and 1 Seth is equals to 0.2 ether, then you get 0.2 ether. While redeem on the line, you actually redeem online converts C tokens to a specified quantity of the underlying asset. So in the case of redeem on the line, you pass in the amount you actually want to withdraw. So in this case, you are not passing 1 Seth. What you're passing in is 0.2 F that you want to withdraw. So that's basically just the stuff. So let's just do a function that's going to actually withdraw it's going to withdraw all the users deposits and interest for him. So we do function withdraw, function withdraw, and then so we actually make it payable. Now, while we're making it payable, we don't actually want, if the user is calling this function, they're not actually sending F, but this function is calling a function that's going to be returning F to our contract. So we should basically make it payable so that we can receive F from compound, because compound is going to be sending us F as a result of this transaction. So we make it public so everybody can call it, really. Public and payable. Yeah, I guess that so now we are going to be calling the redeem function, and then we're going to be calling it by passing in the set balance of the user. Remember that we actually recorded the set balance of the user. So what we'll be doing is do a set.redeem and then set balances of the person making the transaction. So this would get all the balance. This will get the balance of the user, and then we store everything from AAVE, from compound. How do I keep saying AAVE? AAVE is actually another lending protocol that is also quite popular. So that explains why I'm saying AAVE. So now that we we've passed in how much you want to restore, which is everything the user has really. We are going to what we're going to do now is after this line, now our contract asks F to transfer to the user. I mean, well, now AAVE has given us F. So when you do a redeem, as we said earlier, AAVE takes the CS that they gave you earlier, and then they give you back F, your F, and then some, which the sum is actually the interest that you have accrued over the period of time that you deposited or lent them your Ether, basically. So now we want to transfer. We want to transfer this. We want to transfer this Ether to the user, because now the Ether is with us, but we want to transfer it to the user. So first, what we should do is since we already withdrew the user's balance, we should get it to reset to 0. Get it to reset to 0. So that means the user has withdrawn all their balance with us, and then after that we then transfer how much F. So now the question is, how do we get how much F was transferred to us? So well, one way we could do it is do it like we did the deposit stuff, which is get the Ether value of our contract before that transaction, and then the Ether value of our contract after that transaction, and then we get the difference, and then we transfer it to the user. Now another way we could do it is we know how much Seth the user has. Now Seth how this stuff is actually calculated with AAVE is this: your Seth balance remains constant. Now there's an exchange rate that keeps going up and down regardless. Really, it keeps it doesn't actually reduce. It keeps for every block, it either reduces or it stays the same. It does not come down. So this exchange rate, as you can see, we have a function here. So this exchange rate stored is the exchange rate that one Seth goes for. So if you want to get how much F your Seth is worth, what you do is multiply your Seth balance by the exchange rate stored. Really. So that is a way to do it, and I think we're going to do it that way basically. So let's just write a function that actually gets the balance of a particular user in F. So this would help us. So I'm just gonna do it here. So this is the get balance function that actually gets the address of the user. I mean, we pass the address of the user I want to check the balance for. We could actually do message of sender, but we want to also be able to check for arbitrary senders. We want you to be able to check your friend's balance with investors albinus, stuff like that. Yeah. So make it public, returns a unit, and then what we do is we get the set balance of this user address, and then we multiply it by the exchange rate stored, and then we divide by y entry. Why we are doing this is because we are taking into account the decimals of F basically. So So now we could, so to know how much to get to give to this user, we could then do a unit amount to transfer would then equal get balance message sender. So we should actually do this before, because we already setting the set balance to equal 0. So it might not be nice to do it after. So we should do it before we set the balance to 0. So we get the balance of the user. I've not been putting something. Hold on. So it is going to more than with errors. So I want to transfer, we get the balance of the user, set balances, message sender is equals to 0. So now we know this is the amount of S the user is going to get, and then we can basically just transfer it. So like I said, we could do it this way, or we could, get the contract balance before and after. So we could do a unit C balance before is equals to address into bracket this dot balance. Yeah, that's and then we do this again after we done this after, and so then the amount to transfer would be C balance after C balance before. And that would give us that much to give to the user, really. C balance after and C balance before. So I think we should be I think that should do it now. We set the balance of the user to 0, really, and yeah. So and then we do a transfer. So we do payable message sender, which is the person. Message sender, the transfer the amount to restore to transfer value. So we get amount to transfer, and that would conclude it, really. So that's basically everything. Now you'll be able to restore, and so of course you should take my word for it, but then let's also try and do a bit of demo and see how this works, really. And you're going to kill me with errors. So okay, so now that compiles well, I suppose. So we're going to just deploy this now. So let's just we're going to deploy on WinPay. So click on deploy. So that should deploy our contract, and okay, I've taken a bit contracts for the networks for the context a bit. So okay, yeah, so we could then do this and balance. So let's say we send one S. We send one S, and we're going to click on add balance. Okay. So that's an error. Where did that come from? So that's an error. So our balance basically is payable and can accept Ether, and we're depositing this ETH to we're getting the maintaining value amount. Okay, so where's this coming from then? I'm just gonna check the contract address to make sure it's right. So this is going to be I doubt. I think I made a mistake. Oh, sorry. So this is something you should also take note of. The contract address has to be correct. Yes, I think I made a mistake with the contract address. So this is actually contract address of CS on Winkby. As you can see here, this is the contract address. Yeah. So I don't know how did I make that mistake though. So I'm just going to have to deploy again, really. Yeah, I think I'm just going to deploy again. Deploy. Am I not? Oof. Really. I'm on Winkby, right? Yeah, I'm on Winkby. So getting a lot of errors. Oh, sorry. So if you want to deploy, basically you cannot send value while deploying. Oh God. So you can't send value while deploying, basically. So you just do a deploy. Sorry about those errors. And then we do confirm to deploy contract, and it should be done now. And then we could okay, so it's deployed. So we're going to add one ETH. Click on add balance. Please don't keep no errors again. Thank you. So as you can see, we're I am sending on ETH to the contract, and I'm just going to do a confirm. And we're just going to like look at this contract call on the INP and see what's up, and we can also then get the users balance to see that that's actually increased. I should have one mistake that I actually made was I should have made the set balances also public, so I can actually check, so users can actually check the set balance of themselves. I didn't do that. So we can check this contract call again. I think it's mined now. Just a couple of reload. Okay, so as you can see, what's happening here is I sent one ETH, and then the one ETH is transferred to, this is, if we check this contract, this is compound C Ether. So and then the compound contract actually minted 30 compound ETH to me. So I think at the moment 30 point something really. So I think that's the rate at the moment. So one ETH is about 30 point something compound ETH. So now my contract has 30 point something compound ETH. Now this is going to stay the same. It's not going to increase, but the exchange rate is going to increase. So if I leave it for a couple of blocks now and come back and to get the balance, it's actually going to have increased really. So we're just going to probably wait a couple of moments and then try a withdraw. So we could actually just place a withdrawal right now to withdraw all our deposits. Okay, there's an error, which is not good. So what this withdrawal does is it's supposed to get our stuffs from compound. So if we look at the withdraw function and what it does, we could actually find why there's an error. So contract, so probably has to do with some transfer. So see, so let's just follow line by line. We're getting the balance before the transaction happened, and then we're redeeming it. We're redeeming our CS for ETH. What we're going to do again, so we're getting the balance after, then the ETH balance after, and then we're getting the amount to transfer, which is see the balance after minus the balance before, and then we're just transferring that amount really. So where's the error coming from? Where's the error coming from? If we force down this transaction, does it? So So it actually failed. Why? Well, I do not know, but we're going to find out. So I'll actually make a silly mistake again. Restore gets the value. So in order to make withdrawals work, like I said earlier, since if you are withdrawing and we are renaming our set balance, the compound is going to be sending F to our contract. So and in order for your contract to be able to receive F, you have to make it you have to like actually tell it to be able to receive F. And how you do that is by specifying this block of code, this receive function. So this receive function enables your contracts to receive Ether. So with this here now, we basically should be able to now withdraw and deposit. So let's just try it out. Let's just deploy it again. And once it's deployed, we are going to just make it. We're going to make deposit and then a withdrawal. So how we make a deposit is we just do let's see what this deposit one SR, and if you do this and see how the transaction goes, basically. Yeah, it's yet to be mined, or it has been mined. It's just yet to be added to the scan. So if we then check this is set address, these are making transactions, you will see that we can we get this amount, which is how much Seth user now had, which is basically also how much Seth our contract now has, since this user is the only depositor that we have at the moment. If we had another user deposit, then it would have obviously different deposits depending on how much deposited. So you can see what happens here, that our the compound means 30 point something compound is to our contract. So let's then try and withdraw. So withdraw, and like you said, withdraw is going to withdraw everything that we have. So we just click on withdraw. Depends on how you're doing it. Most times you might like have to make sure I'm sending enough gas. I mean, most times you might just leave it like that, but most times you also need to make sure it's enough gas for transaction. And then click on confirm. So if this transaction goes through, you see that the user set balance will be set back to 0, and then you would actually get credited back the Ether that was taken from us. So that's basically how interacting with external contracts work. Once you have that interface, you'll be able to do pretty much everything that you want to do. There's a lot of things you can also do with compound, apart from just borrowing and apart from just lending and and accruing interest. You can also borrow and use it to do some other stuff. Also, when you borrow and you lend, they actually give you which is weird. But when you borrow, when you lend and borrow, they give you bonuses, so they give you some rewards for borrowing and stuff like that. So it's actually a wide area that you can actually start digging into yourself, and it's actually very interesting. If you have any questions, you can just hit me up on Slack on Discord and talk about it. Thank you for watching this video. I hope you learned something. Bye. So I just show over here.